So I hope you're enjoying our discussion of Io, this bizarre first Galilean moon of Jupiter. Just by way of a little bit of wrap up here, I wanted to read you something from, once again, that site, Astronomy Picture of the Day that NASA runs. And here you go. The strangest moon in the solar system is bright yellow. This picture, an attempt to show you how Io would appear in the true colors perceptible to the average human eye, was taken in 1999 July by the Galileo spacecraft that orbited Jupiter from 1995 to 2003. Io's color derived from sulfur and molten silicate rock. The unusual surface of Io is kept very young by its active system of volcanoes. The intense tidal gravity of Jupiter stretches Io and damps wobbles caused by Jupiter's other Galilean moons. The resulting friction greatly heats Io's interior, causing molten rock to explode through the surface. Io's volcanoes are so active that they are effectively turning the whole moon inside out. Some of Io's volcanic lava is so hot that it actually glows in the dark. So there you go. So a couple other consequences, though. So definitely the key takeaway of Io is the volcanism and the heat, just constantly spewing out lava and things. As you might guess, because Jupiter, again, this awful host planet that Io finds its way around, I think I've drawn this a couple times in the past, but if you look at sort of a cross-sectional view of Jupiter then, and you took a cut of it like that, of course, this top layers here are all going to be the gases here. I believe it was the molecular helium and the hydrogen, but as you get lower inside where the pressures start to build, because of all that gas you have above you here, this becomes sort of a liquid, and I'll just sort of put the word core next to it, a liquid core. Now, what would the liquid core be about? Well, that's going to be about generating a magnetic field for Jupiter. And this picture here I've taken from NASA also illustrates what the magnetic field might look like. So imagine then your poor Io here, once again, if the heating and the tidal forces aren't enough, then imagine your poor Io sitting in here just trying to go in your orbit around Jupiter in this crazy magnetic field. Remember, here's what Io looks like orbiting around Jupiter, and I won't even try to pull this off, but if you can imagine all these magnetic field lines coming out of Jupiter here, well, you're having to sort of pass through that magnetic field in Jupiter. So what is that going to do to you? What would that possibly do to a poor planet that's immersed in this huge magnetic field from this beast Jupiter that Io is orbiting around? What consequences would that have? Well, I want to show you one now that we sort of learn about in basic physics. It's a very common effect called the Faraday Factor. So let me see if I can sort of cue this up and let you know what's happening here. So here's a magnet, of course, right here. And this magnet here, you can think of that as Jupiter, because Jupiter has a magnetic field. And so all of these magnetic field lines that you see going around would be like the magnetic field lines I just showed you from Jupiter, would be like all of these lines here. Okay, so just keep that in mind. I can't put a planet in this simulation, but just think of the magnet as Jupiter, and here's the magnetic field line. So the issue at heart then is then what happens when you start moving through a magnetic field? Because that's sort of what I put in front of you. What is poor Io doing immersed in Jupiter's magnetic field? Like, does it have effective at all? Does it affect the planet at all? And so here's the issue. Suppose that this coil with this light bulb on it was Io. And the reason why I'm doing this is because I want to move this around now. Okay, I want to move this coil around with the idea that if the magnet was like Jupiter and this coil was like Io, what happens when this coil starts to move? Well, watch the light bulb. As I start to move, see how the light bulb's coming on? And I don't have to move it towards the magnet, but I can move it in all directions around the magnet. And of course, it stops when it doesn't move. But of course, Io is always moving, right? So as Io always moves around Jupiter, oh, don't let me drag it that far. As Io moves around Jupiter, say up in its orbit, just keep it moving, it looks like the light bulb would light. Now, I understand there's no light bulb in Io and that sort of thing, but in this simulation here, what causes the light bulb to light? Well, electricity causes the light bulb to light. So it is a fact, it's called Faraday's law, that if I move in a magnetic field, a current will be generated. Okay, I'll summarize this for you as we wrap up this video, but again, as I move in a magnetic field, a current would be generated. And the proof is just right in front of you here. You know, here's the magnet, here's the magnetic field, and here's my electrical system that I'm moving in the magnetic field. Looks like I can sort of crank up the field here and make it more intense, but the same thing sort of happens as I move in the magnetic field. I get an electric current. Okay, so I'll summarize this and tell you the ramifications in just a second here. But of course, as Io moves in a magnetic field, what I just showed you here is that if you move in a magnetic field, a current which I'm definitely running out of room here. Let me do a little better job here with this here. Let me just write this up for you here. Yeah, here, better. Okay. So, if I move in a magnetic field, comma, a current will be generated. Okay, and this law, all told in physics, is called Faraday's law, and Faraday is one of the original scientists who worked on this. And so the question that I will address with you in the next video here is, if you have big old Jupiter sitting here with its absolutely ginormously powerful magnetic field emanating space around it, a lot like the Earth's field. Yes, there are auroras on Jupiter. Yes, there's solar wind protection, all those things. And you were the poor moon Io right here, moving in this magnetic field. What happens to you? As we just said, if I move in a magnetic field, a current will be generated. And I just showed that to you in that simulation. So here's Io moving in a magnetic field. Is there a current generated? Oh yeah, stay tuned.